The second part of this question is now to take student one's reasoning and identify things that are incorrect. So we're going to use the same process, but again, we have to explain. And since we've notated things along the way, it makes it easy for us to find the information, and that saves us time. So they have a smaller maximum vertical displacement. All right, so y will have a smaller vertical displacement. Is incorrect. Projectiles experience the same gravitational acceleration irrespective of their masses. So bodies launched vertically with the same V0 will take the same amount of time to reach their peak. And we could even do this. We could say Vx equals AT plus V0x. And we could do Vy equals AT plus V0y. And Vx, they have the same acceleration and they have the same V0. So if V0s and Gs are the same, V0s, Gs, and the tops are 0 are the same, then the times will be the same. So let's see if there's anything else false in this first part. We have a false premise about the smaller vertical distance, which we've already addressed. So that entails the totality of A2. Moving on to A3. Students 2 reasoning are correct. Well, let's see. Student 2, true. X and Y, same vertical displacement. Because of the explanation in A2. So we have true. The kinetic energy is false. Same amount of time to reach the ground. X and Y, same amount of time. To reach the ground. Because the velocities will be the same throughout at the same time. And we could use average velocity. Average velocity is delta z over delta t. If v and v bar and t are the same throughout, then delta z must be 2. We could go on to say that v and v prime are a proxy for each other if we want to be more specific, and say that when acceleration is constant, the average velocity is also the average of these over 2. And therefore, v bar behaves the same as v. And now we shoot on to the incorrect. First thing it's incorrect here is that the rockets have the same kinetic energy. X and Y have same kinetic energy is false, because kinetic energy is 1/2 mv squared, and although they have the same velocity, their masses are different. And thus, so will their kinetic energies. Let's see what else is incorrect over here. So we have true, false premise, same maximal, that was true, the same amount of time to reach the ground. And so though that was the only false thing, is the premise in the second clause. And that's it for number 4. Moving on to B now. Using quantitative reasoning, including equations, derive expressions for the maximum heights by x and y. Express your answer in terms of V0, MR, big MR, y, and other constants, which in this case will probably be g. So we have two equations that govern in this case. We have, and in all projectile cases, we have v, and we'll use y. We would normally use z, but their y is our z. So vz equals at plus v0 z, and our z is 1/2 at squared plus v0 zt plus z0. So we want to find the maximum height. So that is from here to here. Well, what we know about this is that the velocity equals 0 at the top. So Vz will be 0. The acceleration is g, and our V0 is V0. So that means then that our time, or gt, will equal V0, and our time then it will take to do this is V0 over g. Now that maximum height z, the acceleration is g, and the time we just solved for, which is V0 over g squared. And we have V0 z times t, which is V0 g, and z0 is 0. So that leaves us z is 1/2 g V0 squared over g squared plus V0 z squared over g. And just doing some resolution here on our exponents, we're left with z equals 1/2 V0 squared over g. I made a little bit of a mistake here when I brought these over. I forgot this was minus gt. So we have negative V0 like so. When it's squared, it drops, but we keep it over here. And then we have a plus a negative V0 z squared over g, which gives us 1/2 V0 squared g. 1/2 is a minus 1/2, excuse me. So we have minus 1 V0 z squared over g plus 1/2 gives us a minus 1/2 V0 squared g. And if G is minus 9.81, we end up with a positive Z. And the Z in this case is Y. So that gives us an expression for that maximum position. Minus V0 squared over G. Moving on to part C. Derive expressions for the time it takes to reach the ground after reaching their respective heights. So now we're talking about it has reached the maximum height and it is going to come down to the ground. So it's just this second half, which is the free fall. And so we want to express our answers in terms of MR, big MR, HX, HY, and G. So it's almost the same terms. Well, what we know is the time up equals the time down. So if the time up, we figured was V0G, V0 over G from above. And the time down is V0 over G. So we have fundamental constants G and V0. So that's the first way we could do this. We can also